All right, dude, we are live. What's up, guys? This is Dem Keys, and today we're going to continue learning Godot with Rust. I haven't managed to fix the interference issue. I just got busy doing other stuff. There's two things that I need to do here. I need to figure out like the exact cause of the interference because I've gotten some ideas of things that might be causing interference, but I haven't really narrowed it down. Um, I was also supposed to plug this interface along with the extension into my desktop, and I haven't done that yet. I haven't tested that out yet. Once I do test that out, I'll need to make sure that audio is coming through on through over RTMP. And once I've done that, then I need to make sure that I can get the VTuber app to listen to system audio, and hopefully the RTMP thing is part of system audio. Give me a second. I want to hear just how. I'm pretty sure it doesn't sound that great right now on stream, but I can't really do too much about that. We're just gonna have to have a sort of a buzzing, sort of a humming stream. Give me a second. I'm just gonna crank up the volume on my stream. Buzzing, sort of a humming stream. Give me a second. I'm just gonna crank up the volume on my stream. You know what? I think it's okay. I think. Well, okay. To be fair, I'm listening to it on my phone through the phone's speaker. I haven't connected like earphones to hear what it sounds like. But yeah, there isn't too much that I can do about that. I need to do some tests and see what works. For the most part, I'm um, I just want to connect this interface to my desktop and see how well I'm able to capture the audio from there and send it over the network. I'm not sure what's going to happen to the audio quality, so I need to watch out for that as well. I might need to change some settings depending on how good or bad the audio quality is. And yeah, it's also most likely going to put a load on my system. Well, no, sorry, a load on my network, because I'll be transferring the video and the audio over the network, not just the video anymore. Once I get the audio set up on the other system, then I'll also be transferring the audio, unless I can manage to somehow fix this issue that I'm having, or sorry, unless I can somehow manage to fix the issue on this laptop. I'm gonna have to move it over. I'm gonna have to move the setup, at least the audio setup. Sorry, I'm gonna have to move the mic setup over to the Ubuntu desktop. But yeah, I haven't managed to do any of that so far because I got busy doing some other stuff. Um, I was oh, what just happened? What just happened? Okay, yeah. I haven't managed to do any of that because I got busy doing other stuff. I had to move. So yesterday I started um, uploading this year's VODs because this year I haven't uploaded any of the VODs so far. The reason was that I was planning on I was planning on processing each of this year's VODs through the content pipeline to hopefully generate clips and highlights and stuff, and then I would upload the VODs. But then as I was working on the content pipeline, I started to get more ideas for stuff that I could do. And the content pipeline kind of evolved. Initially, the project was just called Auto Clipper, but then as I started to get more and more ideas, the project became about a lot more than just clipping. So now it's called the content pipeline. And because I have some work to do on the content pipeline, so that's why the processing of those VODs got delayed. And because of that, I hadn't uploaded any of them. So what I decided is I kind of gave up on the VODs of January. I'm not going to process any of them to get like clips and stuff. Um, I'm just going to upload all of the January VODs, and I'm going to use all the Feb VODs for processing. Another thing I had to do was move data around. This is more of just my own setup kind of thing. I had moved the VODs over to another machine where I was holding on to them. I'm not going to be keeping them on that machine anymore. I'm going to be keeping them on my on this laptop that I'm streaming off of, but on the Ubuntu side. I'm going to use SSH or SCP specifically to transfer all of the VODs over the network once I'm done uploading them. So basically, I'm going to be holding on to the VOD, uh, just the VOD files, and once I'm ready to process them into bundles, then I'll bring them back um, to my other machine on which I'm gonna be doing the actual, bundle processing and stuff, and then I'll process them into a bundle and then transfer those bundles back to this machine, or well, transfer those bundles for the first time to this laptop that I'm streaming from. So the whole idea is that because there's around, let's say, 400 GB worth of memory available, 400 GB worth of storage available. So that's why I'm going to be using this laptop to store the information instead of having to, squeeze every little bit of space that I can get out of the desktop that I'm currently out of the Ubuntu desktop that I'm currently using to do all the processing. Yeah, yeah. So I have some plans for that. In the meantime, I need to hurry up with the VOD uploads, and I've started the process. I uploaded, I think, 3 VODs yesterday, and I also have a sort of streamlined process for stitching broken up VODs together. So that's great as well. So I don't need to. So basically, it's going to be one VOD per day, or per date. There's only going to be one VOD. There's not going to be more than one. Whereas previously, if a stream got broken up because, maybe my internet connection dropped, or maybe OBS froze, or whatever, for whatever reason, the stream kind of disconnected, and then Twitch's disconnect protection tried to keep the stream alive for, I think they keep it alive for like 90 seconds. If you can get it up in that time, okay. Otherwise, the stream crashes. So yeah, I mean, there were situations where I wasn't able to get it back up in time, and because of that, the stream had to be broken up into 2 separate pieces. And now, thanks to FFmpeg and of course Gemini, who gave me, the right parameters to give FFmpeg to do the stitching, thanks to these two, I'm now able to much more easily stitch these videos and make them into one VOD, so I can upload that VOD. Yeah, yeah. So how how long have we been yapping? Okay, 10 minutes. That's not that bad. That's not that bad. So we can get into it right now. hopefully I'm able to keep my concentration on this one thing instead of getting distracted. So yesterday we spent a whole bunch of time trying to understand the scene tree and the difference between a scene and a node, and how nodes can be packed together into a node tree. So you can have nodes being children of other nodes. And this way you can have a node tree. And when you save that node tree, it gets saved as a scene. That scene can be loaded up as a child node in another node tree, which is interesting because it it allows you to convert this thing or look at this thing that is supposed to be an entire collection of nodes. It allows you to look at that as just one node, and as like one unit, as opposed to looking at it as one big tree. So that's really interesting. That's very powerful. You can do a lot of very interesting stuff using that. But yeah, yeah, we're gonna continue learning Godot. Hopefully, pretty soon we're gonna get to the scripting part of it. I still don't know what all we are gonna be covering in the scripting section. Is all of this like, do we get to, okay, what all is being used here? So we have our, I believe that's a macro. Okay, then we have to implement a trait. I'm assuming iSprite 2D is a trait. We have to implement the trait for player. Is player just like a thing that we made, just a struct? Hold on. Okay, sprite 2D. Oh, okay, so we made, this is a sprite 2D node, and we are representing this node. This is just my guess that this is a sprite 2D node, and we are representing the node using this struct. And then we implement these functions on the struct. Yeah, yeah. Then we implement these functions on the struct. It'll be interesting seeing like the connections that you're able to make, because I don't think iSprite 2D is supposed to have a physics process. I could be wrong. I don't remember what I don't remember the exact like functionality in terms of scripting. I don't remember the exact functionality, the exact the exact default functionality that each node has. So I think physics process, it could be part of every node. Like it's possible that this is just this is like base functionality, because of which physics process is just included by default. I'll have to look into that. I guess once as we keep progressing through the tutorial, it's gonna answer that question. It's gonna tell us. Okay, so this is our node, and in the node we are creating this functionality. Why are there two separate things here? Okay, method declaration. Oh, okay. This is just this is being appended to what was added up there. I just noticed that. Oh God, I just hit. I think I hit end. Yeah. Um, Hold up. Where was I? Okay, class declaration. Okay, then method declaration. We have our init. Okay. Then we have physics process. So physics process does this. Save, run, launching the Godot application. Unfortunately, there is a GD extension limitation that prevents recompilation while the editor is open. before Godot 4.0. This is what I was talking about yesterday. I was mentioning this yesterday that there was this kind of a limitation where you would have to reload. Um, you would have to reload the editor in order to hold on. However, if you don't need to modify anything in the editor itself, you can launch Godot from the command line or even your IDE. Wait, unfortunately, there is a GD extension limitation that prevents recompilation while the editor is open before Godot 4.2. So we are currently on 4. Here we are on 4.5. I just realized that. I need to replace this with 4.6. Okay. This will also be a good experiment about how well does Godot handle projects being opened in different versions. Because like in Unity, for example, if the project was built in a separate Unity version and you try to open it in a separate Unity version, you have to do a sort of upgrade. Usually you're trying to open it in like a later Unity version. There might be some situations where you might want to downgrade as well, but like a lot of times you're doing upgrades because there's a new Unity version out and you need to upgrade the project. So I need to see how that gets handled here. It's possible that maybe this handles it just as well as Blender, because Blender doesn't ask you to, at least in the years that I used Blender, Blender wouldn't ask you to upgrade a project. You can just open it. You can just open up the project in the new version of Blender, and you're good to go. Um, Anyways, okay. Since Godot 4.2, it is possible to hot reload extensions. This means you can recompile your Rust code and Godot will pick up the changes without needing to restart the editor. However, if you don't need to modify anything in the editor itself, you can launch Godot from the command line or even your IDE. Okay, all right. We now add a translation component to the sprite. Okay, all right. Translation, cool, great. Custom Rust APIs. Say you want to add some functionality to your player class, which can be called from GD script. For this, you have a separate impl block, again annotated with Godot API. However, this time we are using an inherent impl. Oh, okay. An inherent impl. So you are implementing functions on a node. You're not implementing a trait on a node, so you don't need to define functions of a trait. You're just defining functions that would actually, okay, this is interesting. Functions and signals. I didn't know this. This is interesting. Okay, you can define signals programmatically as well. That's good to know. Right. So there's going to be a lot that we're going to be learning here. I feel like this Hello World is gonna give us a pretty decent introduction, and after that there is a lot more to explore. We are not done by a long shot. However, the knowledge that we have so far in Godot, I feel like that's gonna be enough to um, do all of this because I have covered generics. Definitely, I've gone over your basic variables, and then there's loops and conditions, and I think I mentioned generics. Yeah, I've covered generics. I've covered functions, structs, traits, generic traits. I think generic structs as well. A whole lot of like generic related stuff. We are currently on, we recently finished closures and we are currently on iterators. And yeah. After that, I think we're going to be moving on to, I forgot what category they fall under, but We're going to be moving on to the heap related stuff. So box, RC, ref cell, and so on. Okay, all right. Let's continue learning. Actually, wait, I'm curious about something here. So what comes after this? We go to using the Godot API. Okay, the so-called built-in types or just built-ins are the basic types that Godot provides. Notably, these are not classes. See the built-in types for so and so. Okay, simple types, composite types. Okay, okay. Oh, these are all the Godot types. Why am I sitting and reading all of these? Yeah. Okay. Cool. Cool. So they're providing us with a mapping of the entire thing. Hell yeah. This will be a good reference. Okay. All right. Let's move on to this. Okay. First look at Godot's interface. This page will give you a brief overview of Godot's interface. We are going to look at the we're going to look at the different main screens and words, dude. What is going on? We're going to look at the different main screens and docs to help you situate yourself. For a comprehensive breakdown of the editor's interface and how to use it, see the editor manual. Wait, there's a separate manual for this? What is this like what part of this index is that a part of? Editor introduction. Okay, we are currently in getting started. Oh, okay, okay. This is under manual. Hold on, I didn't know there was a web editor for this. That's interesting. Actually, let's check this out. Using the web editor. What is this like where is this located? Okay, all right. There is a web editor you can use to work on new or existing projects. The web editor is in a preliminary stage. While its feature set may be sufficient for educational purposes, it is currently not recommended for production work. Okay, all right. Okay, that's fair. That's fair. There would be some limitations. That's understandable. Okay, moving on. The project manager. When you launch Godot, the first window you see is a project manager. In the default tab projects, you can manage existing projects, import or create new ones, and more. Okay, at the top of the window, there is another tab named Asset Library. The first time you go to this tab, you'll see a Go Online button. For privacy reasons, the Godot Project Manager does not access the internet by default. To change this, click the Go Online button. You can change this option later in the settings. Once your network mode is set to online, you can search for demo projects in the open source asset library, which includes many projects developed by the community. Okay, the project manager settings can be open using the settings menu. Great. From here, you can change the editor's language, so and so, so and so, so and so. Awesome. Great. First, look at the Godot editor. Wait, what's this thing in C also? To learn the project manager's ins and outs, read so and so. Okay. When you open a new or or an existing project, the Godot editor's interface appears. Let's look at it. Words, dude. Let's look at its main areas. Holy shit. Why was that? Anyways, by default, along the Windows top edge, it features main menu on the left, workspace switching buttons in the center, and playtest buttons, and the movie maker mode toggle on the right. Okay. Just below the workspace buttons, the open screens. Um, the opened screens as tabs. Oh, hold on. The opened scenes as tabs are okay. Okay, now I get it. The opened scenes as tabs are seen. The plus button right next to the tabs will add a new scene to the project. I actually, up until this point, I had not noticed that button. That's crazy. Okay. Actually, okay. When we recently restarted learning Godot, then I hadn't noticed it. Maybe back in the day when I learned Godot, then I did notice it because this is one of the few ways that you would actually add a new scene, right? Anyways, with the button on the far right, distraction-free mode can be toggled. Oh, this? Okay, this is distraction-free mode. All right, cool. Um, okay. Um, which maximizes and restores the viewport size by hiding docks in the interface. All right. In the center, below the scene selector, is the viewport with its toolbar at the top, where you'll find different tools to move, scale, or lock the scene's nodes. Currently, the 3D workspace is active. Yeah, let's make sure that that's active. Okay. Uh, this toolbar changes based on the context and the selected node. Here's the 2D toolbar. Below is the 3D toolbar. Okay, cool, cool. To learn more about workspaces, read the 5 main screens. I should open that up. Yeah, I also didn't know that these are called workspaces. 2D workspace, 3D workspace. I was looking at it as like a perspective change, perspective shift kind of thing. Give me a second. Yeah, okay. To learn more about 3D viewport and 3D in general, read Introduction to 3D. Okay, we'll open that up as well. On either side of the viewport sit the docks. At the bottom of the window lies the bottom panel. Let's look at the docks. The file system dock lists your project files, including scripts, images, audio samples, and more. Okay. The scene dock lists the active scene's nodes. The inspector allows you to edit the properties of a selected node. Okay. To read more about the inspector. Okay, all right. Docks can be customized. Read more about moving and resizing docks. The bottom panel, situated below the viewport, is the host for many is the host for the debug console, the animation editor, the audio mixer, and more. All right. They can take precious space. That's why they're folded by default. Okay. When you click on one, it expands vertically. Below, you can see the animation editor open. Yep. Okay, we just collapsed the output thing. Here we can open up the animation. Awesome. Great. Bottom panels can bottom panels can also be shown or hidden using shortcuts defined in editor settings shortcuts so and so. Okay, I should keep that in mind. The five main screens. Oh, is that what five main screens goes to? Okay, it's coming to the same. Yeah, okay, never mind. This is introduction to 3D. Yeah, okay. There are five main screen buttons centered at the top of the editor: 2D, 3D, script, game, and asset library. You'll use the 2D screen for all types of games. In addition to 2D games, the 2D screen is where you'll build your interfaces. In the 3D screen, you can work with meshes, lights, and design levels for 3D games. Okay, what confused me the last time that I learned Godot, like years ago, I remember having a confusion about 2D versus 3D space here as well, because I was having a hard time imagining where 2D is and where 3D is within a 3D space itself, because in Unity you are, and like that's where my mind keeps going, even though these are two very different engines. That's the only thing I'm able to reference, because that's the only thing that I have game development experience in. It's not like I keep jumping engines all the time that I can, keep. I can reference many different types of engines. I only have Unity to reference. In Unity, at least from what I remember, switching to 2D was basically switching the scene perspective and also the camera's perspective. Pretty much all it was doing was changing the perspective, changing the way that you look at things. It wasn't. It was all still within the same space, is what I'm saying. Or at least they did a very good job of making it seem like it's all within the same space. But I'm pretty sure it was all within the same space. It was just being handled in very different ways. Um, I'm having a hard time kind of picturing that here. So I need to do some experimentation of my own in order to sort of wrap my head around that concept. Actually, yeah, let me hold on. Unity switch 2D to 3D. Yeah, to change modes, bring up the editor settings inspector and editor menu. Set the default behavior. No, I'm not talking about the default behavior. Um, there's a cube button right in the middle of the axis too. Okay, project settings, editor, default behavior mode. Am I remembering wrong? Because I haven't touched Unity in a while, but I do remember there was a relatively easy way to just. So this is talking about switching the entire project. That's why it's talking about default behavior. I'm talking about like in the scene view, 2D versus 3D, and then in the game view, 2D versus 3D. Like it was really easy to switch between the two. Can't remember exactly what it was. But yeah, it was really easy to switch between 2D and 3D, even in the scene view and even in the game view. In the game view, all you had to do was and this was before SRP. I don't know how things are done in SRP, but in the built-in render pipeline, the way that it was done was you would for the scene view you would switch to 2D. You could also, I believe, you could also have isometric view, and in your for the game view, you would change the settings in your camera, in your game camera, to be either perspective or orthographic. Give me a second here. Okay, all right. Um, enough trying to remember Unity stuff. The game screen. Oh yeah, I was supposed to ask this question to Gemini. I'm gonna bring up Gemini and or well, open up a new instance of Gemini. Hey, so I'm learning Godot. I'm coming from a decade's worth of experience with Unity. Does that sentence make sense? Oh, let me just say I'm coming from a Unity background with a decade's worth of experience in Unity. In Unity, um, we could switch the scene from 2D to 3D, but they would more or less still be a part of the same 3D space, if I'm not wrong. I'm having, oh, also, it was more about how the camera saw things. I'm having trouble imagining a similar setup in Godot. What exactly is going on in 2D versus 3D in Godot? Welcome to the Godot side of things. After a decade in Unity, you're likely used to the everything is 3D philosophy. In Unity, a 2D project is essentially a 3D scene where the camera is. Okay, so I was remembering right. Everything was essentially 3D. Okay, in Unity, a 2D project is essentially. You guys will have to excuse words. You guys will have to excuse me because I haven't touched Unity's 2D side in years. I recently opened up Unity after months of not touching Unity, or maybe more than a year of not touching Unity. And the only reason I opened it up was to make a small change in my VTuber application and to export a Linux build of it. So I haven't done a whole lot of like 2D stuff in Unity in like more than in a couple of years actually. So I was kind of doubting whether I was remembering right or wrong. But anyways, in Unity, a 2D project is essentially a 3D scene where the camera is set to orthographic and locked to a specific axis. Godot, however, treats them as separate but equal engines under one roof. Here's the here's the breakdown of how that mental shift works. The specialized engine split. In Godot, 2D and 3D use completely different rendering pipelines and coordinate systems. Okay. 3D engine use 3D engine uses node 3D. Coordinates are X, Y, and Z, typically in meters. It uses a standard 3D coordinate system. Okay. 2D engine uses node 2D. Coordinates are X and Y in pixels. The y-axis points down, so 0, 0 is at the top left. Oh, okay. I didn't understand what y-axis points down really meant, but then yeah, saying 00.00 is the top left of the screen, that makes sense. Okay, which is standard for 2D graphics APIs, but the opposite for Unity's 2D world space. That is true, because in Unity, um, 00 is bottom left. So going towards the right side is positive x-axis, and going upwards is positive y. Okay, why do this? By having a dedicated 2D engine, Godot avoids the depth sorting hacks often required in 3D based 2D engines. Pixel perfect alignment is easier because the engine is thinking in pixels from the start, not trying to project 3D units onto a 2D plane. Okay, hold on, wait. Pixel perfect alignment is easier because the engine is thinking in pixels from the start and not trying to project 3D units onto a 2D plane. This has me curious about how rendering works. Like what is the rendering pipeline like in 2D versus 3D? I need to ask this question, but there's more to read here, so let me finish reading this. You might be wondering, if they are separate engines, how do I put a 2D health bar on a 3D character or a 3D model in a 2D inventory? Okay. The answer is the viewport. The viewport is the window. Everything in Godot happens inside a viewport. Sub viewports. You can place a sub viewport inside a 3D scene. This viewport can contain a 2D scene. You then apply that viewport as a texture to a 3D object, like a computer screen in a game. Then canvas layers. For UI, Godot uses canvas layer. This is a dedicated 2D rendering pass that draws over your 3D view. It doesn't exist in the 3D world. It doesn't exist in the 3D world, in the 3D world space at all. It's a separate overlay. Okay, comparing the feel. If you're trying to recreate the Unity 2D in a 3D world feel, here's the translation. Space, separate 2D and 3D worlds. Okay. Units. Okay. I feel like I'm gonna need some time to wrap my head around this because it seems like these are different systems, and then there's another system that is handling the rendering to bring all of these things together when like in whatever way you describe, because that's the only way that I can try to understand how how you have like a separate 3D system, separate 2D system, a separate UI system, and then all of that is still able to like work together but using using specific tools and nodes and stuff. I guess I'll have to play around with this to actually see it in action. Maybe seeing it in action is gonna help me understand. Sorry, zoned out. Okay. Units, pixels for 2D and meters for 3D. UI control nodes on a canvas layer. Z-axis does not exist in 2D. Use Z index. Okay, when to use what? Since you have a decade of experience, you'll appreciate this. Don't fight the engine. Okay, all right. Um, Pure 2D games stay entirely in the 2D workspace. It's leaner, and the tools Like tile maps are built specifically for it. 3D 3D game with 2D UI. Build your world in 3D and use control nodes for your HUD. Godot automatically handles the overlay. Okay, 2.5D Octopath Traveler style. I've heard this name, Octopath Traveler. Oh, that's interesting. Yeah, so it's like a that's basically 2.5D. I was about to say isometric, but then isometric seems to follow like a very specific kind of design, which I guess to a certain extent this could 2.5D is better. Okay. 2.5D, you actually stay in the 3D engine, but use Sprite 3D nodes. This lets you use 2D textures while benefiting from 3D lighting and perspective. Pro tip, in Godot, you don't switch the scene mode. You just add the type of node you need. A scene can technically contain both 2D and 3D nodes, though 2D nodes won't render in the 3D cam. Okay. 2D nodes won't render in the 3D camera's frustum unless you're using a viewport container. Would you like me to walk you through how to set up a no, okay, wait. I feel like I've kind of understood the concept, but not really understood it because it seems like there are different systems for 2D, 3D, and UI each. And then there is something that actually, no, then it's not something that's bringing them all together. No, yeah, no. In the end, there's something that brings all of it together. But I'm still having trouble wrapping my head around the concept of these different systems. It's perfectly normal to feel a bit disjointed coming from Unity's everything is a game object world. In Unity, the UI is just a canvas in the 3D world, and 2D is just 3D with a flat camera. In Godot, the quote unquote glue that brings everything together is the viewport. To understand it, think of Godot not as a single room, but as a stack of transparent sheets. Give me a second. Hold on. Just need to check something. Okay, all right. Right, the three world types. Each system has its own base class node. They are physically incapable of interacting with. Wait, each system has its own base class node. They are physically incapable of interacting with each other unless you use a bridge. Node 3D. Wait, okay, so when we create. So here we have root nodes. This lets us create a 2D. This lets us create a scene that works in 2D. This lets us create a scene that works in 3D that uses the 3D engine. And then this lets us create um, a node that lets us work in UI, but I'm assuming using the 2D engine. I'm not sure if it's using the 2D engine or if this has its own separate engine. Let's continue reading this. Right. Node 3D, the 3D world, lives in a world of X, Y, Z. It has lighting, shadows, and 3D physics. Node 2D, the 2D world, it lives in a world of X, Y, pixels. It has its own 2D lighting and 2D physics. Control, the UI world. These are 2D, but they are smart rectangles. They care about anchors, margins, and containers. They don't care about world coordinates. They care about the screen. Oh, so it's like screen, I guess screen space coordinates then. Okay, how they stack. If you look at the top of a standard Godot scene, there's a hidden node called the root viewport. Think of this as the final render box, the standard overlay stack. Imagine you are making a 3D shooter with a 2D HUD. Bottom layer, the sub viewport or main viewport, renders your 3D nodes. Then the top layer, a canvas layer, sits above the 3D render. You put your control slash UI nodes here. The result, Godot draws the 3D world first, then simply pastes the 2D UI on top of the finished image before sending it to your monitor. Dude, I'm pretty sure somebody must have written like an article on understanding Godot 2D versus 3D. Understanding Godot 2D versus 3D. Introduction. Wait, I did open up that introduction to 3D thing, right? The extra z coordinate. The extra z coordinate makes many of the common techniques that helped to make 2D games simpler no longer work. We're creating a 3D game. Is so and so okay? Is there wait? So there's introduction to 3D. Is there an intro to 2D? Yes, there is. So let's open that up. Did I? Yeah, I did. Okay. Oh, yeah. I feel like I need to read through both of these. Maybe not all the way, but like I need to read through both of these to get a better idea. Yeah, I feel like I need to read through each of these. But somebody must have made an article explaining. Hold on, there's a 2D and 3D. Oh, that's physics interpolation. Never mind. Using character body 2D and 3D. Let's see if somebody has linked an article on the Godot forum. Okay, hi guys. As you know, I'm new to the Godot engine. I'm currently using Godot engine 4.4.1. I'm interested in both styles, but I'm not sure where to start as a beginner. Its scripting language, GDScript, is very simple and beginner friendly, but I'm not sure which to choose, 3D games or 2D. What do you guys prefer? I strongly recommend you decide for yourself. Do the 2D and 3D tutorials in the documentation. They will teach you how to use the editor and will make the decision for you much easier. Um, yeah, okay. I'm wondering if reading through each of these is gonna make it is gonna like clear up the doubt that I'm having about how 2D and 3D works because I don't know. I think one of the reasons why I'm getting so confused is because I keep trying to connect it to Unity to try and make sense out of it. But then this is not Unity. This is, its own system and things work differently here. And because I keep trying to connect it to Unity, so that's why I'm having this confusion. Um, how do I go about this? Oh, dude, you know what I want to do? I want to log into Ubuntu on this laptop because now that I have the drivers set up and I have my all of my entire tool set, my entire toolbox set up there, my whole TUI workflow and all of the CLI tools that I need and the entire terminal-based workflow is set up there. Godot is also set up there. So I can like easily open up Godot and start working on stuff. One of the many things that I want to test out is light mapping. Um, I want to play around with the light mapping system there and anything lighting related, in fact, not just light mapping, anything light mapping, anything lighting related, lighting, shadows, shader stuff, any post-processing effects, bunch of different things. I want to play around with a bunch of stuff there. Oh, another I guess important decision that I need to make is whether I want my nah, it needs to be 3D. I was about to say that I need to make a decision about whether I want my VTuber app to be 2D or 3D. But no, I want it to be 3D. Yeah, I prefer for it to be 3D, definitely. Though to be fair, now that Gemini has put things into perspective in this way, what I could do is I could have the entire thing be 2D, but then just the VTuber avatar be 3D. So it's operating in 3D space, and that is then being projected onto 2D, and the entire thing is then being rendered. Oh, I also want to see how heavy 2D versus 3D ends up being in I can test that out. I can test that out on the on the laptop whenever I do, set the thing up. Something that I haven't set up yet is an SSH server. I haven't set up an SSH server on this laptop, and I need to set up the server in order to be able to do coding stuff on this laptop, but from another machine. So I wanna SSH into this laptop from another machine, and pretty much how I'm doing this, like when you guys see me doing this, I'm not actually doing this at the computer where the thing is being captured. I'm doing it on a different computer, and that change is being reflected on the computer where the tmux session is running and where it's actually being recorded, and then that is being recorded by OBS and streamed to the RTMP server. And then this laptop from which I'm streaming to Twitch, this laptop is pulling that RTMP feed, and that's how you guys are seeing it. But yeah, okay. Wait, let me go back to this. Okay, the reason Godot keeps them separate is math. In Unity, if you move a 2D sprite 10 units to the right and your camera is 50 units away, how many pixels did it move? It depends on the field of view. Okay? In Godot 2D, if you move a node 10 units to the right, it moved exactly 10 pixels. The math is 1 to 1. Because the math is fundamentally different, Godot uses different draw calls for each. 2D nodes are drawn using a 2D coordinate system, and 3D nodes are drawn using a 3D matrix. Okay, one scene, multiple tabs. In the Godot editor, you'll see 2D and 3D buttons at the top. These are just different viewports for the same scene file. If you have a 3D node and a 2D node in the same scene tree, you will see the 3D node when you click the 3D tab, and the 2D node when you click the 2D tab. They're like ghosts to each other. They exist in the same file. Okay, so in this case, when it's saying scene tree, it means, I'm assuming it means node tree. There can only be one root node, right? No, hold on. Okay, let's click on 2D. Um, can we do another root? I don't see. Yeah, I don't see an option for another root. Yeah, no, I'm not seeing an option. Okay, so this is in 2D. Now, what if we add 3D? Okay, this is a 2D thing, right? Let's add a child node. Um, from what I understand, I can do mesh stuff. Oh, actually not mesh. I think it's sprite, but I don't have um I don't have like a I don't have a texture to give it. Uh oh. Oh, okay. I think they have like procedural textures here as well. You know what? We can use a noise texture. Is that noise, or is that just an error? Yeah, is this supposed to be noise, or is this supposed to be an error? Okay, we'll stick with gradient for now. This is our gradient texture. Um, are there, hold on, I need to check the settings for zooming. Wait, Godot editor, editor zoom. Godot editor zoom without uh middle mouse button. 3D pan slash zoom without middle mouse button should be, yeah, okay, somebody asked this legit 10 years ago. Okay. Shift drag. That maybe that works in 3D. I'm not sure. That does not work in 3D. Um, oh, control. Okay, it's control. Um, does that work in 2D? Yes, it does. Okay. Control, middle mouse, drag. So I need to check if there's I need to check if there's a way to avoid the middle mouse button. I'll have to set up something similar to Blender. Just a second. Okay, trackpad hint. There's an in the 3D editor, plugins, editor settings. Um, where do I do these settings? Editor settings. Okay. Then key map. Oh, shortcuts? Yeah. Okay, right. Zoom. Viewport zoom modifier. All right. So if there's a second modifier, wait, hold on. What is the other option down there? Wait, my mouse. Sprite frames. Control equal, control KP add. How do I, okay, control minus, control subtract, control equal, control add. Oh, you know what? I'll take it. What's the button for 3D? Never mind. Um, yeah, this works. This works. I'll look into the keypad thing later on. I need to look at this on a different screen because the screen that I'm currently looking at it from, in, on, the currently that I'm the currently the screen that I'm currently looking at it on. There you go. That is, it's making it hard for me to see all the details. Once I see it on this slightly bigger screen that I have, I'll be able to set things up. Okay, anyways, I was doing something, I was doing something here. So we can create a child node, node 3D. Here there's a sprite 3D. No, let's place a cube. No, mesh. I think it's mesh instance 3D. That automatically shifts to that. Okay, do they have a cube? Box mesh. Okay, let's go for a box. So 2D is not able to see 3D. 3D is not able to see 2D. But they both exist in the same scene. It's just that their rendering is being handled differently. Dude, I need some time to wrap my head around this concept. I definitely need some time to wrap my head around this. Wait, okay, I'm still kind of having trouble understanding it. I think it's because I keep, hold on, keyboard. I think it's because I keep connecting or comparing it to Unity, whereas these are two very different engines. So, am I getting this right? A scene can have um, a scene can have um, 2D and 3D nodes in it. Um, 2D and 3D have different base nodes each. Did it say base node or base class? I mean, it's kind of the same thing in this context, but then I just want to get the terminology right. Base class node. Okay. And okay, so a scene can have 2D and 3D nodes in it. 2D and 3D have different base class nodes each, and depending on the view you have, or depending on the workspace you are currently viewing the scene from, um, the respective nodes with those specific base class nodes with that specific base class node will be rendered. If so, what decides during runtime which workspace is going to be used? I'm still trying to wrap my head around the concept of there being multiple different engines to render each of these things, and then there's something that's kind of stitching them together. Also, what exactly is it that's stitching them? Is is that the system root's job? Okay, you are getting very close. All right. Okay, when you realize that Godot doesn't switch between engines at runtime, it runs them simultaneously in a specific order. To answer your specific question, the viewport is the stitcher, and the scene tree is the manager. Okay. What decides which engine runs? At runtime, both run at the same time. Think of it like a movie production. The 3D engine is the film crew shooting on a physical set, 3D nodes. The 2D engine is the motion graphics team adding the HUD, subtitles, and overlays, 2D nodes. Uh, yeah. Godot doesn't pick one to show you. It renders the 3D world into a buffer. Then it renders the 2D world on top of it, and finally shows you the combined result. Okay. The stitcher, the viewport. You mentioned the system root. In Godot, every game starts with a root viewport created automatically by the engine. A viewport is essentially a rendering surface. It has two main jobs. It holds a world 3D that it holds a world 3D. This contains the physics environment and lighting for 3D nodes. and it holds a canvas where all 2D nodes, Node 2D and Control, live. When a scene runs, the viewport says, okay, 3D nodes, draw yourself to my 3D buffer. Now 2D nodes, draw yourself to my 2D buffer on top of that. Okay, okay. So I guess what I'm supposed to be doing here is looking at it as we have 3D space, and then 2D space is something that's going to be um, overlaid on top of it. So anything 3D is going to have 2D overlaid on top of it. Okay, okay. The scene tree structure. In Unity, a scene is a flat list or a simple hierarchy. In Godot, the hierarchy is the logic. Look at this common setup. Node, generic folder node, camera 3D, the 3D eyes, mesh instance 3D, a 3D box, canvas layer, the 2D stitcher layer, label, 2D text saying health. All right, how Godot handles this at runtime. Camera 3D sees the mesh instance 3D. The 3D engine renders this. The canvas layer tells the engine, ignore the 3D camera, draw this label directly to your screen pixels. And then the viewport merges them. Okay, why is this different from Unity? In Unity, if you put a UI button in the scene, it technically has a rect transform, which is still just a 3D coordinate in a world that the UI camera happens to be looking at. In Godot, if you move a 3D character, you are changing values in meters. If you move a UI button, you are changing values in pixels. They are fundamentally different math universes. The Unity logic, everything is a 3D object. Some just look flat. The Godot logic, 2D and 3D are different math problems. So let's use different calculators and just layer the results. Okay, okay. I think I'm slowly starting to understand it. Okay, this is slowly starting to make sense. Sorry, zoned out. Okay. Okay, this is slowly starting to make sense. Um, so anything, wait, but before I go further and try to explain it to you so you can tell me if I've understood right. Ah, okay. Um, where was I? Sorry, I had to sneeze and then my mind is just all over the place. Explain it to you so you can tell me if I've understood it right. Um, am I right to, am I right in understanding that um, 2D nodes have a base class, have a base node 2D class, 3D nodes um, have a base node 3D class, and UI nodes have some control related base class, and depending on what the base class is, and depending on, no, wait, and which engine renders the node is determined by the sorry, zoned out. Okay. Um, renders the node is determined by the base class node of that node. Also, I feel like I understand the 3D graphics pipeline where we have various stages like vertex, geometry, fragment, and a bunch of stuff between and some even after fragment. But but how does the 2D pipeline work? You are hitting the nail on the head. Your intuition about the base class determining the engine, or more accurately, the rendering server, is exactly how Godot's internal logic is branched. The trinity of nodes. You've correctly identified the three pillars in Godot, in the Godot source code. When a node enters the scene tree, it registers itself with the rendering server. Node 3D registers with the 3D rendering pipeline. It needs a transform 3D, basis plus origin. Then node 2D registers itself with the 2D rendering pipeline. It needs a transform 2D, rotation, I think divided by scale, plus position. Then control registers with the 2D pipeline, but adds UI layout logic, anchors, margins, and containers. The 2D pipeline, how it's different. Since you know the 3D pipeline, vertex, geometry, fragment, the 2D pipeline will feel like a specialized flat version of it. In a 3D pipeline, the GPU is constantly calculating perspective projection and depending, no, depth testing, not depending, and depth testing, Z buffering, to decide if a pixel is behind another. In Godot's 2D pipeline, sorry, no, Godot's 2D pipeline simplifies or skips these steps, um, skips these to stay pixel perfect. The 2D stages. Transform stage, vertex. Instead of a complex 4 by 4 model view projection matrix, it uses a 3 by 2 matrix. It converts world pixels to screen pixels. Okay, there's no Z depth math here. The painter's algorithm, sorting. This is the biggest difference. This is the biggest difference. In 3D, the Z buffer handles what's in front. In 2D, Godot uses tree order. Nodes at the top of the tree are drawn. Oh, that tree order. Okay. Nodes at the top of the tree are drawn first, so that's the background. Nodes at the bottom are drawn last, that's the foreground. You can override this with a z index, but it's still just a sorting instruction, not actual 3D depth. Batching in Godot's 2D secrets. What? Batching. This is Godot's 2D secret sauce. Since 2D games often have thousands of sprites, the 2D engine batches similar sprites into a single draw call automatically to keep the frame rate high. Fragment stage, just like 3D, this handles the textures, colors, and 2D lighting, normal maps for 2D sprites. The stitching. Wait, there's more. You asked about the system root. In Godot, the very top of your game is a window, which is a type of viewport. This window has a canvas and a world 3D. When a node 2D is in the tree, it draws to that world's canvas. When a node 3D is in the tree, it draws to the window's world 3D. Okay, the window has a canvas and a world 3D. Okay, all right. Wait, the window has a canvas and a world 3D. Let's let's do something here. Let's save this as I don't know, node 01, and okay, the run button is F5. I don't think you guys can see the thing that's being built. Okay. I don't see anything in 2D. I don't see anything in 3D. Okay, let's close that. Uh, oh, there's a game view here. I just noticed this. There's a game view here. Embedded game size is based on so and so. Is there a way for me to have the thing be embedded within the editor? Okay, wait. So what I was what I was worried about is here. Is there a way to expand this? This is the root node. This is not showing. Hmm. Okay, this is not showing what I thought it's gonna show. Yeah, yeah. Okay. I guess I'll ask this question to Gemini that where's the where's the canvas and the world 3D, because okay, it's possible that the world 3D and the canvas are just buffers, so we don't exactly see them because they later get merged together, or rather node 2D or the canvas gets overlaid on top of world 3D, and then that's what's being displayed to us. Okay, to solidify this, imagine you want to draw a sprite. In Unity, you create a quad in 3D space, put a texture on it, set the camera to orthographic. The GPU still does 3D math, it just looks flat. In Godot, you use sprite 2D. The engine tells the GPU, forget perspective, just take this texture and draw it at these XY pixel coordinates. Ready to verify? Okay, try to explain to me, if I have a 3D player and I want a 2D health bar to float over its head, which space, 2D or 3D, would you put the health bar in? And how do you think they talk to each other? Okay, so my understanding is that I would create um, I would create the health bar in 2D space, specifically make it a control, because that's, wait, no, hold up. Float over their head. Okay, yeah. Specifically make it a control, um, because it's meant to be UI. And I'm guessing the 3D player will be rendered and stored in World 3D, while the UI will be rendered and stored, well, hold up, rendered by the 3D engine and stored and so and so, while the UI will be rendered by the 2D engine and stored in the canvas. And then what exactly, okay, and then the viewport will overlay the canvas on top of the world 3D and display that. Spot on. You've successfully deprogrammed the Unity everything is a 3D object mindset. In your scenario, the 3D engine is doing math in meters and the 2D engine is doing math in pixels. Because they live in different math universes, they don't naturally know where each other are. The handshake problem. Since the health bar is a control node, 2D slash pixels, and the player is a character body 3D, so 3D slash meters, you need a way to translate a 3D coordinate into a 2D screen position. That's basically rasterization, right? In Godot, you use the 3D camera to do the heavy lifting. The 3D camera, wait, no, hold on. You need a way to translate 3D coordinates into a 2D screen position. Okay, okay. The 3D player has a position of, say, 10 on X, 2 on Y, negative 5 on Z. The 3D camera has a built-in function called unproject position. This function takes that position and calculates where would this point land on the user's 2D monitor screen. It returns a 2D vector. You can then tell the 2D health bar, set your position to so-and-so. Oh, that is... Hold on, dude. That's interesting because I was thinking about it the other way. I was thinking that we would need to convert this to like world space coordinates and then place it accordingly. But no, here we are still. Hold on, dude. That's crazy. Wait, no, there's a couple of things I need to ask you. A couple of things. Um, I had no idea that I could do the unproject thing. My mind immediately went to converting the UI space, or well, the screen space UI position to world space to place the thing properly. But I wasn't taking into account that the UI is purely screen space. I'm assuming it's purely screen space. I think so. Because it's giving like pixel space kind of, or pixel position, like how do I even say this? Like, okay, the values that it gave like 800 by 450 pixels. So like that's what I'm saying. It's giving positions in pixels. It's not even giving like a coordinate system. The coordinate system is the pixels. purely, even not, let's not even say screen space. It's purely pixel space. Okay, next. Um, you mentioned, I'm starting to forget the questions that I had. I need to go back and ask those questions quickly before I forget everything. In Godot, at the very top of your game is a window, which is a type of viewport. The window has, you mentioned in the game or in Godot. In Godot, at the very top of the game is a window. I'm assuming this is our root viewport that is at the very top of the scene tree, which only exists at runtime. A tree which only exists at runtime. Am I right? Also, um, what exactly does the stitching here? Then there was one more question that I had, which I need to go back and like, now I'm forgetting what the question was. Transform stage, no, no, no. Um, but no, this is good. I'm slowly starting to understand. Oh, yeah. Um, a scene tree typically loads um, a scene. A scene usually has, or typically has, um, what do you call it? Has a root node. Let's say that as a root node, under which all the other nodes are created. So what I'm wondering is, does it make a difference whether there is, whether the root node is a node 2D, node 3D, or control node? Like, what if I have a node 2D root, but then I create a bunch of, let's not say a bunch, then I create a sprite 2D node and a mesh, okay, a sprite 2D node with a gradient texture, and a mesh instance 3D node with a box mesh. Oh wait, there was a thing about bridging here. If you don't want to deal with the with that math and just want the health bar to physically stick to the character's head in the 3D world, you can use a sprite 3D. I should keep that in mind. Okay, yeah. A sprite 3D or a viewport sprite. This is a bridge node. It lives in the 3D world, but it takes a 2D texture like your health bar and draws it on a plane inside the 3D scene. Okay, all right. Now to answer this question, you are asking the you are asking the exact right questions to deconstruct the Godot way. Let's tackle these one by one because they get because they get to the heart of the engine's architecture. The screen space versus world space logic. Your instinct, your instinct was the Unity way, move the UI into the world. Godot's way is project the world onto the UI. Okay, that's an interesting way to look at it. Um, because the UI control nodes is pixel based, it's much cheaper and sharper to just tell a 2D label, hey, the camera says the player's head is at pixel so and so, go sit there. Okay. This avoids all the fuzzy scaling. Um, this avoids all the fuzzy scaling and lighting issues you sometimes get with world space canvases in Unity. All right, the window and the stitcher. You are 100% correct. When you hit play, Godot creates a scene tree. At the very top of this tree is a hidden node called the root window, which is a viewport. What does the stitching? It is the rendering server. Okay, think of the rendering server as a separate worker thread that doesn't care about the nodes. It only cares about items. Node 3D sends a 3D mesh item to the rendering server. Okay, sorry, kind of got distracted. It only cares about items. Node 3D sends a 3D mesh item to the rendering server. Node 2D sends a 2D canvas item to the rendering server. The viewport acts as the manager. It tells the rendering server, draw the 3D items first using this canvas, then draw the 2D items on top of that result. Okay. The stitching is literally just the order of operations in the GPU's frame buffer. The root node mystery. This is a common point of confusion for Unity devs. In Godot, the type of root node of a scene does not restrict what can be inside it. If your root node is a node 2D, you can absolutely have a mesh 3D, a mesh instance 3D as a child. Here's what happens at runtime. The node 2D root will register itself to the 2D side of the engine. The sprite 2D child will draw in 2D. The mesh instance 3D child will register itself with the 3D world of the current viewport. The catch, if you have a mesh instance 3D in a scene, it needs a camera 3D to be seen. If your root is a node 2D, you can still add a camera 3D as a child. The engine doesn't care about the hierarchy. No, it doesn't care about the hierarchy's type for rendering. It only cares about the individual node's type. Every node looks up the tree until it finds the nearest viewport. It then asks the viewport, please draw me. Important note, while you can mix them like this, it's usually messy. If you have 3D nodes inside a 2D branch, they will appear in the 3D workspace. If you move the parent node 2D, the 3D child will not move. Why? Because the node 2D only has a transform 2D, but a 3D node needs a transform 3D. They can't share the transform data. Let's look at the scene tree at runtime. When you run your game, the tree looks like this: main loop, root, your loaded scene root, okay, sprite 2D, mesh instance 3D, and camera 3D. The summary: the root node type is mostly for your organization and for providing a base transform for children of the same type. A 3D a 3D root, a node 3D root is a 3D scene, a node 2D root is a 2D scene, but they are both just containers that live inside the viewport, which is the real boss. Okay, I'm curious about where you've gotten all this info from. Are there any articles or specific Godot manual pages I should read to understand this? The architectural separation of powers is one of Godot's most distinct features compared to Unity. If you want to dive into the official source of truth, there are three key areas of the documentation that cover this. The viewport is the master. Okay, using viewports. There was there was a thing here using viewports. Hold on. There was a link. Inspector doc, 5 main screens. Where is it? Okay, using viewports. Let's click on this. Um, okay, then there's canvas layers. Then there's coordinate systems and math. 2D coordinate systems and 2D transforms. Because you used Unity's units, you should check out so-and-so advanced rendering server. Okay, there was also the rendering server. All right. So this is pointing me towards towards the using viewports page, which is under rendering. Overview of renderers, introduction, and so and so. This is under manual. Let's go to manual. Uh, rendering. Overview of, no, is it an overview? What am I looking at? I'm just looking at rendering. Okay, so let's open this. Using viewports. Right, so this is the entire like rendering thing. Oh, back up. Most rendering topics are covered in 2D rendering and 3D rendering. Let's open up these as well. See what this points towards. Okay, all right. Let's continue with this. Okay, switching between renderers. Okay. This is going a lot more lower level. Oh, hold on. No, yeah, I can get information. I can get information here. Yeah. Okay. Also, yeah, let's open up this. In in order to see the game, we need to have a surface on which to draw it. That surface is a root viewport. Sub-viewports have a variety of use cases. Okay, okay. Oh, is this why I couldn't see the thing? Because I didn't have a camera? So I need a camera 2D as well. Let's add a camera 2D. Uh, where is it placed though? Oh, I think it's right here. Okay. Let's run this. I still don't see it. Let's close this and add a camera 3D as well. And this, the frustum is here. Right. Okay. Now let's see. So this is showing 2D. This is showing 3. Let's just do input. Wait, what does input is input like both of them together? Viewports are also responsible for delivering properly adjusted and scaled input events. Okay, this is confusing. I'm gonna have to see why I'm not able to get this to work. I must be doing something wrong here. Yeah, I'm probably doing something wrong here. Let's try creating a new scene. Let's make it a 3D scene. Uh, let's add mesh instance 3D. Let's do a box mesh. Okay, then let's do camera 3D and bring the camera here. Okay, let's save this as node 02 and run. Yeah, that's still not displaying. What is going on here? Is it displaying anything in this window? What is the game view? No, it's not displaying anything in this window either. That's odd, dude. I guess I'll have to look into this. Yeah, I'll have to look into this later on. In the meantime, now where were we with this? Was it rendering? It wasn't rendering, was it? 5 main screens. Hmm. Okay, give me a second here. Okay, so I don't know what this person is doing, but they have a nice background setup. So we are going to be heading over to their stream. So I'm going to be ending the stream here. Give me a second. Let me set up the raid. Okay, right. So that's going to be it for today's stream. I'm going to stream again tomorrow. We've got a pretty good streak going, and we're probably gonna be doing some more Godot because got some good progress being made here. But that being said, I hope you guys have a nice day, and I'll see you all next time. Peace.